Now we shall discuss some important problem from exercise 1A, inequalities, and all the problems we have chosen from schema of a book. So first we will try to recall some basic facts. So here the recall is if ABCD, if ABCD all are positive real numbers and greater than 1 and greater than 1, then we have done in workout problem a plus 1 into b plus 1 into c plus 1 into d plus 1. This value is less than 8 ABCD plus 1. But in the exercise, we have given a similar kind of problem. And in this problem, it has been asked, problem number 7, exercise 1A, let ABCD are positive real numbers. Let ABCD are positive real numbers, each less than 1, each less than 1, then prove that 8 into ABCD plus 1, this value is greater than A plus 1 multiple B plus 1, C plus 1, D plus 1. So here you will see in the workout problem it is given greater than. Now in the exercise it is given less than 1. Now we will solve this problem. So here solution. First you need to think what are the given condition. Here the given condition is A, B, C, D all are positive real numbers, and second condition is A less than 1, B less than 1, C also less than 1, and D is less than 1. What we have to prove? We have to prove that 8 ABCD plus 1, this value greater than A plus 1, B plus 1, C plus 1, and D plus 1. Now, for proving this inequality, so what is given? Since A less than 1, B less than 1, C less than 1, and D less than 1, from this we can write A minus 1 less than 0, B minus 1 less than 0, C minus 1 less than 0, and D minus 1 is also less than 0. And from this condition we can write, we just take first two terms, A minus 1 into B minus 1, that must be greater than 0. And if we take last two terms, that means C minus 1 into D minus 1, this is also greater than 0. As we know the fact, what is the fact? If x less than 0, y less than 0 be two real numbers, so that implies xy is greater than 0. The product must be greater than 0. That means the product of two negative number is positive. Now, since A minus 1, B minus 1 greater than 0, from this result we can write AB plus 1, just to multiply it and simplify, we get A plus B, AB greater than AB plus 1 greater than A plus B. And here you can also just add AB plus 1 both sides. So it will be 2 into AB plus 1 greater than A plus B plus AB plus 1. And that we can write 2 into AB plus 1. This is greater than A plus 1 into B plus 1. So what we have done? We have done here, we get A minus 1 into B minus 1 greater than 0. That implies 2 into AB plus 1. This is greater than A plus 1 into B plus 1. Similarly, so that means 2 into AB plus 1, that is greater than A plus 1 multiple B plus 1. Similarly, in the same way, we can prove that C minus 1 into D minus 1, that product greater than 0 implies 2 into CD plus 1 greater than C plus 1 into D plus 1. So that means from here we can write 2 into CD plus 1 greater than C plus 1 multiple D plus 1. That we take as Roman 2. So now we multiple this 1 and 2. So what we will get? Therefore from 1 and 2 we get A plus 1 multiple B plus 1, C plus 1 into D plus 1. That value less than 4 into AB plus 1 into CD plus 1. This is Roman 3. Now again we have seen 0 less than A less than 1 and 0 less than B less than 1. That implies AB, that value is greater than 0 and less than 1. Also 0 less than C less than 1, 0 less than D less than 1. That also implies 0 less than C, D less than 1. Now, just as previous result of 1 and 2, we can write here AB plus 1 into CD plus 1. That value less than 2 into AB CD plus 1. So this is our 4. Why? Because you just recall the fact, if 0 less than x less than 1 and 0 less than y less than 1, then what we will get? We will get x plus 1 into y plus 1. This value less than 2 into xy plus 1. That we have proved in 1 and 2. That is happening for any positive real number. Each of the real number is less than 1. So here just you take your xy equals to AB, x equals to AB and y equals to CD, and you will get the result 4. So now from 3 and 4, what you will get? So therefore from 3 and 4, we get A plus 1 into B plus 1 into C plus 1 into D plus 1. This is less than 4 into this value. 4 into AB plus 1 into CD plus 1. Just you put the value, this inequality from 4 here. So what we will get? This is 4 into 2, that means 8 into AB CD plus 1. This is basically by 4. So here we proved that therefore we prove that A plus 1 into B plus 1 into C plus 1 into D plus 1, this value less than 8 into ABCD plus 1. So this is proved. Now we come to another important problem. Problem number 9, and this is given Problem number 9. This is given exercise 1A. What is the problem? The problem is, if n is a positive integer, and greater than 2 and greater than 2, then prove that in factorial whole square, this value greater than n to the power n. So how we will solve the problem? Here we come to the solution. Here it is given, what is given? N belongs to natural number and n greater than 2. What we have to prove? We have to prove that in factorial this value greater than n to the power n. So this is our job to prove it. So now, since now here n greater than 2, so we know some basic facts. So we know that for 1 less than r less than n, r minus 1 must be greater than 0 and n minus r is also greater than 0. And from this result we can write r minus 1 into n minus r, that product is greater than 0. So that means here you can write r into n minus r plus 1, this value greater than n, and n is greater than 0 for r equals to 1, 2 up to n minus 1. Now putting the value r equals to 2, 3 dot dot up to n minus 1 successively, what we get? We get 2 into n minus 1. If we put r equals to 2, that will be 2 into n minus 1. This value will be greater than n, and that is greater than 0. Next we put r equals to 3. So 3 into n minus 2, this is greater than n, again it is greater than 0. Last, if we put r equals to n minus 1, so n minus 1 into 2, this value greater than n, again it is greater than 0. So now we are taking product of all the above inequality what we will get? We get 2 into 3 up to n minus 1, that whole square is greater than n into n. How many times? This is basically n minus 2 times. Okay, so from this we get 2 into 3 up to n minus 1, this whole square is greater than n to the power n minus 2. So this is the relation we are considering as 1. Now again we know n square is also greater than 0. Why? Because n is natural number and n is greater than 2. So now we will just product n square on the both sides of 1. So what will happen? 2 into 3 n minus 1 into n, that whole square greater than n to the power n. So that we can write as n factorial. So n factorial whole square greater than n to the power n. So here the question may be asked as a MCQ type. So the MCQ type question may be let n be a positive integer such that n is greater than 2. Then which of the following inequality inequality is true? Option A, n factorial, this is greater than n to the power n. Option B, n factorial whole square greater than n to the power n. Option C, n factorial whole square less than n to the power n. And option D, n factorial whole square, this is less than equals to n plus 1 whole to the power n. So here option B is correct and all other options are false. Now we come to the next important question. Question number 13. This is exercise 2A. Let A, B, C, D all are positive real number such that not all equal, then prove that one 2 into a cube plus b cube plus c cube, this value greater than a square into b plus c plus b square into c plus a plus c square into a plus b. This is also greater than 6abc. What was the second problem? The second problem is b plus c by b square plus c square plus c plus a by c square plus a square plus a plus b by a square plus b square. This value is less than 1 by a plus 1 by b plus 1 by c. Next third, a cube plus b cube plus c cube multiple 1 by a cube plus 1 by b cube plus 1 by c cube. This value greater than 9. And fourth, bc by b plus c plus ca by c plus a plus ab by b plus c. This value less than a plus b plus c by 2. Okay. So here not the a, b, c are positive real number. Now the question is how to solve this kind of problem. So now we'll come to the solution. So what is given? Given a, b, c, d all are positive real number, not all equal. So that means here, since a, b, c, d are not equal, so whatever the inequality will use, it will not in equal sign. It is either less than or greater than sign. So now we'll start the first problem. Since a, b, c, d are positive real number, since a greater than 0, b greater than 0, c greater than 0, and not all equal. So In that case, we can write a plus b must be greater than 0 and a minus b whole square, this is also greater than 0. From this we can write a plus b multiple a minus b whole square, that value is greater than 0. So from this we can write a plus b into a square minus 2ab plus b square is greater than 0. So just you will do the multiplication and simplified it, you will get a cube plus b cube. This value greater than a square b plus b square a. So this is 1. And in same way, if we take AC and BC, so what we will get? We will get similarly, we can prove b cube plus c cube. This value greater than b square c plus c square b. This is 2. And c cube plus a cube. This value is also greater than a square c plus c square a. So this is our 1, 3. Now we just add 1, 2 and 3. So from 1, 2 and 3, just we'll simply adding all this inequality. What we will get? We'll get in the left side 2 into a cube plus b cube plus c cube. This must be greater than a square into b plus c plus b square into c plus a plus c square into a plus b. So this we need to prove. You will see 2 into a cube plus b cube equals to greater than a square into b plus c, b square into c plus b plus c square into a plus b. So that part is proved. Now we'll come to the second part. That means we'll show that a square into b plus c plus b square into c plus a plus c square into a plus b. This part is greater than 6abc. So now we'll come to the second part of the problem. Now, so a square into b plus c plus b square into c plus a plus c square into a plus b. That we can write b into a square plus c square plus c into a square plus b square plus a into b square plus c square. And from this we can write, now we'll move to say, we know a minus b whole square is greater than 0 as a, b are not equal. So from this result we can write a square plus b square must be greater than 2ab. And in same way, b square plus c square is greater than 2bc and c square plus c square greater than 2c. Just we put these things here. This is greater than b into square plus c square. This is greater than 2ca. C into square plus b square. This is greater than 2ab. And a into b square plus c square. This is greater than 2bc. So that will be 6abc. So what we have done here? So that means a square into b plus c plus b square into c plus a plus c square into a plus b. This complete value is greater than 6abc. This is our capital A that we consider as capital B. So therefore from A and B we conclude that what we conclude, from A, 2 into a cube plus b cube plus c cube is greater than a square into b plus c plus b square into c plus a plus c square into a plus b, and this is also greater than 6abc. So So that part is done. Now we come to the second problem. Problem number 2. In that case, since it is given A, B, C is greater than 0, all are positive number, not all equal. So from this we have to prove that what we will prove? B plus C y b square plus c square plus C plus A y c square plus a square plus A plus B y square plus b square. This value less than 1 by A plus 1 by B plus 1 by C. So we will prove this inequality. How to prove? So without loss of generality, we assume that because they are not equal, we assume that A is greater than B and B is greater than C. That means in the real line, this is A, this is B, and this is C. So now it starts from B minus C whole square plus B plus C whole square. So what will be the value? 2 into B square plus C square. And from this result we can write 2 into B square plus C square. This is greater than B plus C whole square. And here equality does not hold because A, B, C are not equal. Strictly inequalities holds. So here we can write 2 into B square plus C square by B plus C. Because all are positive real numbers, so B plus C must be greater than 0. At B, C are positive real number, so when we will divide, the inequality does not change. So that greater than B plus C. In similar way, and from this we can write B plus C y b square plus C square. So that means we are thinking about this term. So this is less than 2 by B plus C. And that value must be less than 1 by C. Why? Because we consider here B is greater than C. That means B plus C greater than C plus C, that means 2C. And that in that case we can write 2 by B plus C. This is less than 1 by C. So in similar way, if we think about A minus B whole square plus A plus B whole square, in that case similarly we can prove that A plus B by A square plus B square, this is less than 1 by B, and C plus A by C square plus A square, this is less than 1 by A. Just we add all this inequality, what we will get? So adding above inequality, we get B plus C by B square plus C square, C plus A by C square plus A square, and A plus B by A square plus B square. So this value obviously less than 1 by A plus 1 by B plus 1 by C. Again our proof is done. Now we'll come to the third problem. So this is also one of the important problem, the third one. So here first we recall some basic facts, basic inequality, and then we'll come to the problem. So let A1, A2, An Bn positive real numbers and not all equal, and PQ are rational numbers not all equal, and P comma Q are rational numbers. So then we have one standard inequality, A1 to the power P plus Q plus A2 to the power P plus Q plus An to the power P plus Q divided by N. This value is greater than or less than A1 to the power P plus An to the power P by N multiple A1 to the power Q, A2 to the power Q plus An to the power Q by N. So here, when the greater than or less than inequality holds, this holds according as P and Q have the same sign, So that means either they are greater than 0 or they are less than 0. Either they are both positive rationals or negative rational, then greater than equality holds. And if they are opposite sign, that means P is negative, Q is positive, or P is positive, Q is negative, then less than inequality holds. So same sign greater than and opposite sign for less than. Opposite sign. Okay. So if we recall this result, from this result we can prove. So now we come to the problem. Here we just take A1 equals to A, A2 equals to B, and A3 equals to C. And you know all are positive real numbers. They are not equal. And we consider here P equals to 3 and Q equals to -3. Why? You will see what we have to prove. Yes. P, Q, P, A to the power Q, B to the power Q, C to the power Q, and that we can write A to the power -3, B to the power -3, C to the power -3. So our P will be 3 and Q will be -3. And they are basically opposite sign. They are opposite sign and opposite rational number. Okay, one is plus, another one is minus. So therefore, by the above fact, what we say? A to the power 3 minus 3, B to the power 3 minus 3, C to the power 3 minus 3 by 3, because here n is basically, n is 3 positive number we have taken, so n is 3. So if they are opposite signs, so we will take the less than symbol. So this is less than A cube plus B cube, or P is 3, C cube by 3 into A to the power -3, B to the power -3, C to the power -3 by 3 again. So what we will get? So here we will get A cube plus B cube plus C cube multiple A to the power minus, that means 1 by A cube plus 1 by B cube plus 1 by C cube. This value greater than 9. So again we proved this inequality. Sometimes this question has been asked in different competitive examination. What was the question? The question is basically MCQ type. Let ABC are positive real numbers with ABC are positive real numbers not all equal, then the least value the least value of the expression a cube plus b cube plus c cube multiple a to the power minus 3, b to the power minus 3, c to the power minus 3 is option A is 3, option B is 9, option C is 1/3 and option D is 1 by 9. So option B is correct. Here you will see this value is greater than 9 always. So that means this is the least value. So the least value is 9. And all other options are false. Now we come to the problem 4. So what has been asked here? BC by B plus C plus CA by C plus A plus AB by B plus that is less than A plus B plus C by 2. So what exactly given? It is given A, B, C all are positive real numbers, not all equal. So what we have to prove? We have to prove that BC by B plus C, CA by C plus A, AB by A plus B, this value is less than A plus B plus C by 2. So that we have to prove. So how to prove this type of problem? Again, we are thinking about the first term of this inequality. First term of this inequality, BC by B plus C. So we'll do whatever we'll do just taking B and C. So we have that we know B minus C whole square, or you can write B plus C whole square minus B minus C whole square, that will be 4BC. And for need B plus C, so from that we can write B plus C whole square. This is greater than 4BC. Equality does not hold because they are not equal. So only the stick symbol will continue. So why? Since B minus C, this whole square always greater than 0 as B not equals to C. And we know x square is always greater than equals to 0 for all x belongs to R. So from this result, we can write 4BC by B plus C. This value less than B plus C. So from that, BC by B plus C, this is less than B plus C by 4. This is 1. Similarly, if we take AB and CA, we will get the similar kind result. So similarly, if we take AB, so that will be AB by A plus B. In similar way, it will be less than A plus B by 4. And if we take A and C, so that will be CA by C plus A, and that value will be C plus A by 4. In similar way, we will get this result. Now we add all these values, because if we see these additions, we will add 1, 2, 3. So adding 1, 2 and 3. What we get? We get BC by B plus C, then CA by C plus A, plus AB by A plus B. This value less than 1 by 4 A plus B, B plus C plus A plus B plus C plus A. So that means this will be BC by B plus C plus CA by C plus A plus AB by A plus B. This value less than A plus B plus C by 2. So here also we proved this inequality easily. So this is one of the important problem here. Now we'll come to the problem. The problem is problem number 12. This exercise 1A that we have proved in previous part, that means inequality part 4. You will see the proof that is already done. You prove that 1 factorial multiple 3 factorial multiple 5 factorial multiple 2n minus 1 factorial this value greater than n factorial to the power n. So please see the previous video and you will see the proof. So this part is done. Now we'll come to the next problem, problem number 14. This is also exercise 1A. Let ABC, XYZ all are real number and a square plus b square plus c square equals to 1. X square plus y square plus z square, this is also 1. Then prove that minus 1 less than equal x plus by plus cz, this is also less than equals to 1. That we need to prove. So now we'll come to the solution. First you will think what is given in the problem and what you will do. These are the two important. You need to think. So what are given? Given A, B, C, X, Y, Z all are real number. Along with it is given the value of a square plus b square plus c square 1. The value of x square plus y square plus z square equals to 1. What we have to prove? We have to prove that minus 1 less than equals to x plus by plus cz. This is less than equals to 1. Now the question is how to prove this problem. So we'll start. So by using an important fact or recall. The recall is if we show x square less than equals to a, from that you can write mod is less than equals to root a, or you just take here lambda, so root lambda, and from this you can write minus lambda less than equals to s less than equals to lambda. So just we will use this simple fact and we try to prove. Here you just consider x as x plus by. So now we'll start from that whole square term, x plus by plus cz, this whole square. So that is less than equals to a square plus b square plus c square into x square plus y square plus z square. Why? Just here we use the simple Cauchy-Schwarz inequality. Cauchy-Schwarz inequality. Okay, because all are positive real numbers and we have two set of positive real numbers A, B, C and X, Y, Z. Now the question is when equality holds. So here equality holds when A, B, C either A equals to B equals to C equals to 0 or X equals to Y equals to Z equals to 0 or both, or they are linearly dependent or ABC and XYZ, these two sets are linearly dependent. So this are just by using the Cauchy-Schwarz inequality. And you know a square plus b square plus c square equals to 1 and x square plus, just we use these two given conditions. So what we will get? We will get x plus by plus cz whole square. This is less than equals to 1 into 1. So that means from this we can write x plus by plus cz that modulus value less than equals to 1. So that means minus 1 less than x plus by plus cz. This is less than equals to 1, and equality holds under this condition. So this is also proved. Here the question may be asked in MCQ type. As MCQ type, let XYZ ABC are real number be such that summation square equals to 1. Summation square means a square plus b square, such that a square plus b square plus c square equals to 1 and x square plus y square plus z square equals to 1. Then the value of mod of x plus by plus cz is option A, this is 1, option B, the greatest value, the value of the greatest value of this 1, minus 1, 0, and option D 2, 0, 2, 3. So option 1 is correct. All other options are false, because here we observed in the previous problem this modulus value less than equals to 1. Under this condition, we just recall the previous result. Here x plus by plus cz, that modulus less than equals to 1, where all ABC XYZ are real number and a square plus b square plus c square equals to 1 equals to x square plus y square plus z square. So this part is done, and also we have done a series of good problem here. Thank you so much. Next class we will continue exercise 1B.